Hello everyone. Today we will be talking about R packages. So we're going to start with how to install an R package, what happens when you install an R package, and then we're going to move on quickly to creating our own R package. And we're going to do an example for creating a package to interact with the National Weather Service API to get forecasts. Okay, so let's open up an R session. You've probably all done things like this, where you say install.packages of some package. I'm going to install maps. So maps is a package for creating plots of maps. And it's going to make me pick a crayon mirror. Let's go with, I don't know, Michigan. So let's look up here. So it says installing package into this directory. So we'll navigate there in a second. It asks us to select a crayon mirror. We've selected University of Michigan. And then it's downloading something. So CRAN is the comprehensive R archive network. They kind of manage all of the R packages and the official R program. And each R package is hosted here, and you can see it's downloading a file called maps 3.4.0.tar.gz. So this got downloaded to our computer, and then it's doing a bunch of stuff. So it's installing this package, and it runs a bunch of compilers. So this is all code we don't need to dive into. And then at the end, it says installing help, package indices, and then it says downloaded source packages are here. I think it deletes this actually, but so what I want to do is quickly look at what happens to your computer when you install this package. So it says that there's installing something into here. So let me grab that. So on your computer, it may look slightly different, but this is the default directory where packages get installed on my computer. So let's just look at these. It's a whole bunch of packages. Each one is indexed by its package name. So we can go into maps. That's the one we just installed, and list the files. And so this is what an installed package looks like on your computer. It's basically just a directory with a bunch of things in it. Now we're not going to dive into what is in all of these subdirectories and files. Some of the things will look the same. So when we go to create a source package, which is the directory you have to create a package. For example, description, we're going to create a file that looks like that. We're going to automatically create a file that looks like this, so on and so forth. Okay, so this is what happens when you install a package on R. It downloads something from the internet, and it saves it in a specified directory on your computer. Now, if we go here and say, we're already in R. So if we want to invoke the package, to load all the functions and data sets in the package, we say library maps. And so this makes things available. So you can say like map state. This creates a map of the U.S., lower 48 U.S. states. Okay. So it somehow knows, this library function knows where to look to find all the package functions. And if we look at the documentation for library, we can see that there's an argument called lib.loc equals null. This is where the package libraries are located. And the default value is null, which corresponds to all libraries currently known to .libpaths. So there's a function in R called .libpaths that tells you where your packages are installed by default. So it just selects the first one by default, which matches what we have over here. Now, I don't recommend doing this at the moment, but if you wanted to install a package somewhere else, you can modify your call to install.packages. You basically change where lib is, and it's just going to put the package somewhere else on your computer. And when you invoke the package, if you install it in a non-default location, you'll have to specify that lib.loc argument to library to match where you installed the package. So we're not going to do that, but that's something you can do. Sometimes that's useful if you want to keep multiple versions of packages installed on your computer. We're going to spend the rest of the video talking about creating your own R package. And I want to spend a little bit of time motivating why you might want to do something like that. So what I'm going to do is open up an R script. And this is a pretty common scenario for which you'd want to think about creating an R package. So I have an R script here, and the script is designed to interact with the National Weather Service's API. So an API is basically an organization will set up a web interface for users to grab data or other items from their databases. So it's an interface. And National Weather Service has a nice one for inputting like longitudes and latitudes and grabbing forecast data and observational data. So I wrote a little script to interact with that, and I'm going to show you what it does, and then we'll start making a package. So the idea is that if we wanted to use this code in a convenient way in other things we're doing on our computer, we would package up all the code, which means putting it in a special format, and install the package on the computer. And then if I wanted to use all these functions in another script, at the top of that script, I would just say library, and then name of the package. We're going to call it Weather API 1. And then I would be able to go ahead and call any of the functions in this script without having to define them and load them in. So it's a convenient way to reuse functions. Another reason is that you made this forecast system in R and you showed it to someone. They thought it was really cool and they want you to share it with them. Well, you can package everything up and send them the source to the package, and they can install it on their computer and use it. And then if it's really useful to a wider audience, you can create a package and submit it to CRAN, and they check to make sure everything is okay. And if it passes all their checks, it'll get hosted on CRAN, and then anyone in the world can download your package and use it. So there's kind of a few different reasons for installing a package. It could just be for yourself locally to make some functions usable to yourself. You could share it with friends, or you could share it with the whole world. So we're just going to make it available, the package we make it available locally, so that we can. So let me take you to the National Weather Service API. They've set up this service where you can download pricing. It's all free. You don't need a authentication key, and you can just go ahead and use it. And then there's documentation for this thing. Let me just show you real quick. We're going to be using, let's see. I think we'll be using grid points. So basically, you can type in a URL to the browser. Let me see if they have examples here. you can type in a specific URL to the browser, and it will give you back information from there. Okay, here's the help. So for example, you can type in a URL like this, and it will give you information about the National Weather Service forecast for that latitude and longitude location. In particular, it gives you a link for how to get the forecast for that latitude longitude point. And so we're going to write what's over here in the R script are basically functions for creating those URLs, strings with those URLs, and then grabbing the information from those URLs and then putting it back in R in a format that's useful for us. So that's basically what these functions do. This one takes in a latitude and longitude and gets that information from the URL. You saw in the raw text for the URL, this is in a format called JSON, and there's an R package called JSON Lite for reading in JSON files. Basically, it takes that text file and turns it into a list. Let me show you how this works. So I'm creating a URL, my URL, print it out, and then if I use the from JSON function, it will go to that URL and grab that information, that JSON file, and it'll put it in a list. Okay. In particular, it contains these links that we're going to use to further get forecast information. So I wrote a function to just do this. And if I define that function, I can call it. So now I have the weather list. And then I wrote another function for grabbing the URL. So basically, we take in the previous weather list object, and then we extract the $properties $forecast object. And I'm using HTTR package to get the information from that URL. And then I'm using both HTTR and JSON Lite to process the information and read it into R. And I'm adding a few different properties, namely city and state and the coordinates. And I'm giving it the class weather forecast. So if I define that function, I can run it. And it will give me that forecast information in another list. So you can see here there's text with the forecast information. Now this is kind of hard to look at, so I wrote a print statement for this forecast object, and print is a S3 generic function, which means you can write methods for specific classes of variables. And the way you do that is you just append .weather forecast, or whatever the class of the object you want to write a method for is. Here we defined it to be weather forecast. And this is just a regular function. And all I'm doing in this function is processing the text strings, and then I have some cat statements to print out text strings associated with the forecast. So if I define that function, I can call it, and this prints out the information a little bit nicer. And you can call it by saying print.weatherForecast, the function directly, or you can just call the S3 generic function. So it will look at the class of this object and then point to the specific method for that class and then call it. And also if you just type in forecast, remember that it calls print forecast, it will print out the forecast. Okay, so these are a collection of functions. I also created a data set. This is just a data set with latitude, longitude coordinates for a bunch of cities in upstate New York. So I've created some functions. I created a data set, And basically I want to be able to use these objects, these functions in this data set in other projects in a convenient way. And the most convenient way to do that is to create an R package. So that's what we're going to do next. The plan here is to take you start from scratch, take you step by step through the process of creating an R package. But I've already gone through these steps, so I'm going to just show you quickly what the finished product looks like. This is going to be like one of those cooking shows where we take you through the steps and then we show you what the endpoint is. So this is an R package. I'm in a directory that you'll have access to called package weather API 1. And if I list out the files and directories in that directory, it looks like this. So there's data. This is where we're going to store that upstate cities object. There's a description, which we're going to create, and you saw a preview of what that looks like. RStudio is going to automatically create this file. Inst is going to, this is kind of, let's look in here. So inst, I created a few extra scripts that are really not part of the necessities of the package. These are just, I'll show you what these are, just to have some additional tools that the user can use if they navigate to the installed package. You're going to need this for your project, so this is why I put this in here. So basically we have an R script in here, very short R script for interacting with the package. And then just for fun, I put in a bash script. The idea here is you might want to create a executable on your computer to print out the forecast every day, and this is just an example of how you might do that. Okay, so these are kind of not that important parts of the R package. They're actually not required, but that's what instance. Man will hold the documentation for your R package. Namespace we'll talk about a little bit more. This tells you which functions and objects are available to the user of the R package. R will contain R scripts that define functions. These are things that get ignored when the package gets built. This is a RStudio file. Don't need to worry about that. This will hold tests for the package. We'll talk more about that. Basically, the main idea is that when you create a package, you want to make sure it works. And it's very easy to break things as you're developing the package. So you change how one function works, and another function calls that function. And because you change the one function, the other one doesn't work. So the way that people test that their code works is they write a test for each function and just automatically run the test to see that everything works. You can also create vignettes for the package. This is for our package. This is just going to be an R markdown file that gets knitted when the package gets built. And then this is a RStudio file. So that's the finished project, but we're going to start from scratch. So I'm going to do this in RStudio. They have a lot of tools in here that make the package creation process pretty convenient. So I'm going to go to File, New Project, and I'm going to create a project in a new directory. It's there's these different options for our package. We're not going to use any of these RCPP options. This is for adding C++ code to your package. We're just going to build a plain one. So I clicked R package, and it's a package. I want to distinguish it from our other one, so I'm going to call it Weather API 2. No source files. We're going to start clean, and we're going to put it let's make sure we put it in the right place. Yeah, in package. And we're not going to create a new Git repository, and we're not going to do this. So I'm going to click Create Project. And you can see, so let me go up. So next to Weather API 1, it created Weather API 2 and automatically set up some of these files for you. In particular, it created a file in this R directory called hello.r. And the reason for this is they just want to show you how to create a function for your package. So what we're going to do is just immediately delete this because we're not going to use this. And we're going to put in our own files here. So let me go up. So basically the process of creating a package is kind of building up this directory, checking that everything works, and then building it and sharing it. So we want to put some R code in here. So that's the first thing we're going to do. Right now this directory is empty. And I've already done this, so let me just move the files over. Okay, so I've put in these 4 files, and we're going to take a look at what they are. We're going to start with points. So this is what our package function file looks like. I've just put in a single function here. I'm calling it getGeoData. It takes in latitude and longitude. This is basically the same function that I had in that script. But then there's all this stuff around it. So we're going to spend some time talking about all this stuff. So this is the documentation for the function. So what these comments do is they create the files that are necessary when you go and type in question mark get geodata. So this is kind of specialized code. The system is called RStudio to create that documentation. This is a really convenient way to do it because the code for creating the documentation is put right here next to the function itself. And so everything is all in one place. It used to be that you had to write the documentation in a separate file. But what this does is it automatically creates that separate file. Okay, so this is there. Let's look at the content of these comments here. So our oxygen comment is defined by a regular comment character followed by a single quote. So this tells the R package system that this is a Roxygen comment. There's a title for the function. So this should be something short that's going to get displayed in large on the screen. And then there's a description, and this should be followed by one line here, commented line. So this can be a longer description. And then you do another commented line. And then usually the next thing that you'll document are the arguments to the function. And we do that with the @param tag. So the syntax is @param and then the argument name and then a description of what the argument is. So we have 2 arguments in getGeodata, lat, and lon. So we have 2 param lines. Now it's possible to say, you can say lat, lon, and then you would just say coordinates of, so you can document multiple arguments on one line, but we're doing it in 2 lines here. And then you also have to say what the function returns. So this function returns a list, and it has the following components, and then there's some specialized syntax for creating bulleted lists. So this is syntax for creating a bulleted list. And then it's also useful in your documentation to include examples of how the functions are used. So if you do the @examples tag, you can put in just regular R code here. So this is just a comment. This is a line where we call get geodata and print out some information. And then, and basically that's all the example does. And then the last line here is @export. And this tells your package that you want this function to be available to the users of your package. So when they call library weather API 2, they will be able to call this function. Now, if you don't have this line, they won't be able to call it. So why would you ever want to do that? So sometimes you have a package where you have a lot of like little helper functions that aren't really necessary for the user to interact with. Then you might not want to export those functions. So, because what can happen is if you load in the package's functions, those function names can be the same as function names that are already in base R, and that can cause all kinds of conflicts and unintended consequences for your users. So the general principle here is only export the few functions that you really need the users to have access to. Now you can put multiple functions in the same file. It's a good idea to group functions that do similar things in the same file. In this package, I just have one function for file, which is perfectly acceptable, but if you have a big package with lots of functions, it's a good idea to group them together in the same file. I also have a function called get 7-day forecast. And then, so this is you saw this function before. This actually grabs the forecast information given the geographic data. So in the examples here, you call get geodata, and then you input that into the get 7-day forecast function, and then print it out. Likewise, I've documented the function with Roxygen comments here. Okay, and then quickly we'll look at print. This is just the function to print the weather forecast. Okay, now there's another file here called data.r. We're going to come back to that in a minute. So let me go back up, and I want to talk about the description. So when you create the package in R, it will automatically create this description file. And there's several tags here. So you have the package name, you have the title of the package. So we're going to go in and modify these. So I'm just going to call it National Weather Service API for R. We want to put in our author name. I'll show you how to do that in a second. And the way we're going to put in the author, we won't need the maintainer tag. Actually, let me pull this up for you. I'm just going to copy this. So there's you can change the author tag to be authors at R, and this is R code, and you can document each author with a call to the person function. You don't need to know much about that. You can basically just copy this syntax here. And when you add the role CRE, that tells R that the maintainer is this person as well. Okay. And I'm just going to copy the description over. This is a longer description. If you want to, you can include URLs here. So this takes you to the National Weather Service documentation for their API. For the license, basically you have to pick a license. I'm not going to go talk about the differences between them. I just picked one, GPL2. Encoding is the text encoding. So UTF-8 is the default. Lazy data, we'll talk more about that in a second. When you have data sets in your package, this tells R whether you want the data sets to be loaded when the package is loaded, or whether you want them not to be loaded, in which case you'd have to call the data function to load the data. Let's see what else. Oh, our package uses, you can tell that one function used functions from other packages. So we have to include an imports tag. This is a really important part of the package because one of the main reasons for creating a package is to tell the user what else needs to be installed in order for the package to work. So if you try to install this package, it's going to check that you have these other two packages installed. And if they're not installed, it'll try to install them. And if it tries to install them and fails, it's going to give you an error. It's not going to let you install this package. So this is a really important component. It kind of makes sure that when you install the package, it's actually going to work because you have all the dependencies installed as well. Let's see. These are going to get created automatically for us, so I'm going to leave those out. So imports are things that are absolutely necessary for your package to work, and then suggests are things that are not necessary for it to work but are useful for doing certain things with your package. These get created when we create tests for the package, we'll come back to, and when we create a vignette for the package. So that's going to require R Markdown and knitr. And these are going to get added automatically when we invoke the use this package. Okay, so we've updated our description, and this is going to get updated further as we add things to the package. Okay, now that we are partway into creating our R package, we're kind of deep in the development process. I want to talk a little bit about some workflows for developing your code. So typically, you're going to be writing functions, you're going to be testing them out, making sure they work. And there's some convenient functions for doing those things for you. So one of them is called load all. So as you write a function, say I'm working on print.r, and I change how something gets catted out. Maybe I want to do an extra new line here. And I want to test how that looks. Basically, I have to load all the functions again. Oops. Load all the functions again. And then start calling them. Oh, we need to run this. And then see how things look. So I added an extra space, I think right here or here. And maybe I don't like that, so I'm going to go back and get rid of that extra space and load everything again and then call the print again. Okay, maybe that looks nicer to me. Okay, so this is kind of how the package development process works. You're going to be changing things, and then you're going to want to load the changes, and then you're going to want to call the function. So I just set up a little script here called scratch weather where I have some code that I'm running over and over again. Okay. Now, there's another DevTools function called document. So another thing that you're going to be working on is writing that documentation. So writing those comments, these things, and you're going to want to look at them But you need to kind of rebuild the documentation before you look at again. So if I run DevTools document, oh, I got an error. Upstate cities is not an exported object. Okay. So this is interesting. I added that data.r file, which talks about the upstate cities object, but I haven't actually added that yet. So this is actually good. So this is like things that happen as you're developing a package. You try to document it and you get an error. So let's try to fix that error. So the problem is that in Weather API 1, this is the original package. There's an object in the data directory called upstatecities.rdata. So what I want to do is, first of all, I want to create the data directory in Weather API 2. This is the package we're working on that doesn't yet have that object. And I want to copy that file over. All right, so now I have that file, and I'm going to run document again. And I got a warning here. So the existing namespace file was not generated by ROxygen2 and will not be overwritten. So that's bad. We want this document function to update that namespace file. So let's actually open that up. This is what the namespace file looks like. Now, this says it was generated by ROxygen2, but this says it was not. So I don't know what's going on there. What I'm going to try is just deleting this file. And I'm going to try again to document. It did not. Oh, that's because we're in Weather API 1. Let's go into Weather API 2. I'm going to delete. Oh, and let's look at that. Okay. So that was the issue. We were in Weather API 1. That one was generated by ROxygen2. Okay, so this is the default namespace that gets created when you create an R package in RStudio. Since we're using ROxygen2, we don't want to use their default. We want to let ROxygen2 create the namespace. So I'm going to delete this one. And now I'm going to go to DevTools document. And now everything works. So it wrote the namespace file. And this looks like the other one that was in Weather API 1 that we just deleted. We can always get it back by running document again. Okay, so now here's an opportunity to talk about what the namespace file is doing. The namespace is the list of objects and functions that are available to the user. And yeah, this is the way ROxygen2 creates it. So we have a S3 method, which is just a function. It's a print method for the weather forecast objects. So this is the way it documents it. And then it also exports two other functions, the get geodata and the get 7-day forecast. And you notice there's a comment up here, generated by ROxygen2. Do not edit by hand. You should follow that. So don't try to edit this file. Make sure that DevTools document creates this file for you. Okay, so that's the namespace. It tells us which package functions are available. Now that we've created the documentation, actually let me show you what happens. So when you run DevTools document, it creates these files. Actually, we deleted hello.rd, so let me get rid of that. So for each of these functions, it creates a documentation file. So let me just peek at this. Just so you don't have to create these. DevTools documents will make them for you. But let's look at what these are. This is why this ROxygen2 is really useful, because It's kind of a simpler format to create the documentation than this is. It's not that much simpler, but it's a little bit simpler. But more importantly, it keeps the documentation next to the definition of the function. So one thing that commonly happens is you'll be editing your function and you'll change, for example, what the argument is. And since the documentation is right there with the function, you can quickly update the documentation to change the @param tags. Okay, so this is just to show you what gets put in this man directory. All right, and I also want to look at, let me close this, the documentation. So we can now call getGeodata, and it will pull up one of these. So now we've created our own documentation file for each of our functions. And it looks just like it looks when you look at documentation for other functions in R. Okay, so that's looking good. Now when we go to build our package, it's going to complain if we don't create documentation for our data object, so that upstate cities object we put in data. And the way you do that, it's a little bit weird because it's not like there's a file that contains text for the definition of the data set. It's just a .r data file. So to create the ROxygen documentation for that, we just create another file in the R directory, and I just called it data.r, and this contains ROxygen 2 comments designed to document that upstate cities data object. So like before, there's a title, there's a description, and you need a @format tag. So this is a data frame. It has 8 rows and 3 columns. And then here's how you describe the columns of that data set. And then importantly, you have to put the name of the object in quotes below the documentation. Another thing to know about the data object, there are rules for how these data objects have to be saved. So the important rule that you'll need to know is that if I create a data frame or any other R object with a name called upstate cities, when I save the R data file, I have to call the R data file that name.rdata. So the object is called upstate cities, and then the file is called upstate cities.rdata. If you recall, the name, if you're just saving objects as RData objects, there's no rules in R for how the name of the file has to be related to the name of the objects in that file. But for R packages, there is. You have to use the same, you have to store one object in this RData file, and the name of that object has to be the name of the file name before the .rdata. Okay, so that's important to remember. So once we saved it in there, we create documentation in data.r, and then when we run DevTools document, it creates documentation in man for upstate cities, and this is what it looks like. So this is automatically generated when we call DevTools document. Okay, there's 2 more things that I want to talk about. The first one are tests for your package. So we're in Weather API 2. We don't yet have any tests in our package. So all I'm going to do is I'm going to copy over the tests. Actually, let me do this differently. So there's a useful package called use this. And as you're developing the package, if you want to add tests to your package, you can type, actually let me get this, library, use this, use this. And then we'll do use test that. So when we call this function, it's going to update our description to include all the information that's required for test that. And then it's also going to create a testing directory for us. So I'm going to type use test that. And it printed out some of that information for us. Setting after package, adding test that to suggest field of description, and setting this to 3. So let's take a look at that. So it added this here and this here. It created a new directory, tests, test that, and a file test.that.r. So here's this new directory, tests. This we're not going to worry about. This is how it sets up the tests. But there's a new directory called test that. There's nothing in it right now. And this is where we're going to put the files that we use to test our code. So what I'm going to do is go back to the terminal and just copy over the tests. And I created 2 tests, one for this geodata function and one for this forecast object. These both use a package called test that, and this is how you use it. So there's a function called test that. You give it a description of the things you're trying to test, and then the second argument is a block of R code. And this is the R code that you're going to run to test that your functions are working properly. And in each of these tests, there should be a function that starts with expect underscore. There's a bunch of different functions like this. I'm just using a function called expect equal. And that just has 2 arguments. It has the 2 objects, and it checks that those objects are the same. So the general idea behind tests is you try to predict what could go wrong with your functions and check that those things haven't gone wrong. So when I call get geodata, I want to make sure that it's giving a list with these 5 elements, named elements of the list. And if so, then everything is okay according to this test. But if not, it's going to throw an error, and that means something got screwed up in the test. Now, the philosophy for writing tests is, there's really no way for most functions to actually have a definitive test that your function works in the way that you expect it to work. But you try to be defensive and try to guess how things could go wrong and check whether those things have gone wrong or not. So this is a very simple one. You'll probably do more complicated tests. But you may have several tests, so you can actually put multiple expect calls in a single test. And you may have multiple calls to test that in the same testing R script. So I just have one here. You could have multiple of these. And inside of this one, I just have one expect call. You could have multiple of these as well. Okay, so this is an example of a test. I also made one, and these are pretty simple ones. You'll probably want to do things that are more complicated. I also made one for the get 7-day forecast function. It's the same sort of test. It just makes sure it's a list with the same list elements. Okay, so we've added our test files, and now we're going to actually run the tests. So there's a convenient function called test in the DevTools package. So if you run this, it will actually run the test. And we passed. You can see up here, I actually ran it before and it failed. So this is what a failure looks like. I think my Wi-Fi went out as it was running the test. So I reconnected and now it passed. So this is what pass looks like. So I ran devtools test, loaded the package, tested it. There were 2 tests, and both of them passed. And then it prints out information at the bottom. None failed, no warnings, none were skipped, and both of them passed. So this is a passing test. This is where you want to get. And so you run your test using devtools test. So the workflow is going to be like you're modifying functions, you're loading them in, you're kind of running some scratch code, and every once in a while you run the tests. And every once in a while you update the test with new information. So that's basically the general workflow. When you're updating documentation, you're going to want to run devtools document. When you update the code and you want to load it in, you call load all. And then when you want to test things, you call devtools tests. And oftentimes you'll fail, but hopefully things will get printed out so you can figure out quickly how to fix things that fail. Okay. One more thing I want to show you in package components are a vignette. So right now we don't have any vignettes in this package, but if you look at the completed package, there's a directory here called vignettes, and if I go in there, there's a file called vignette.rmd. I'm just going to cat that. And this is just an R Markdown file with some code in here to run the package. So the basic idea of a vignette, as opposed to a test or as opposed to the examples in the documentation, is that these are kind of longer form, or intended to be longer form expositions of what the package does. So the one I have here is pretty short, but it does show how to load in the data that's in the package, what the data are, and how to get geographic data for a city and get the forecast and to print out the forecast information. Your vignettes are going to be longer usually. This is just a short one to show you how to do it. Okay, so we want to use vignettes in our R package. So we don't actually have them here. If we look in files, we don't yet have a vignettes directory. And we're going to use the use vignette. And so this comes from the use this package. It's a really useful package, actually. And I'm just going to call it vignette. I'm just going to call it vignette. You don't put the extension here. And when I run this function, it's going to update the description, and it's also going to create a vignettes directory with a file vignette.rmd. So run this. It says I added knitter to suggests, updated the vignette builder in the description. We'll look at that in a second. Added this to gitignore, created the vignettes directory, and created a file vignette.rmd. Okay, so that's good. And if I look in here, it created this file, which it opened for us automatically. All right, so what I'm going to do here is just copy over that code. So here's my vignette information, and then I'm going to save it. So this should be updated. Now I want to check that this works. So basically I just need to knit the vignette. No package. Oh, so we actually have to build the package. So that's a good segue. So if if we want to build the package, we select clean and rebuild. And now let me try again to knit. And that worked. Okay. So we're going to come back to these build things in a second here. So we had to do that to make sure we actually had the package available to us. All right, so this here's the vignette. Created a HTML. You can change it to PDF if you like. Loads the package. Here I'm just loading in the data set, printing it out, figuring out which row corresponds to Ithaca, and then calling getGeoData on that latitude and longitude, getting the forecast, and then printing it out. And here's our nice forecast. So today, nice day in April in Ithaca. It's going to be 80 Fahrenheit, a little windy, and then there's going to be a slight chance of showers and thunderstorms after 4 p.m. Okay. Need to retire as a weather forecaster. And I've printed it out for 4 periods, so it has a little bit more information. Okay. So again, the point of a vignette is to have kind of a longer form documentation for what your package does. And easiest way to do that is with R Markdown. So typically you'll want to add text to here in addition to your code. All right, now there's one more component I want to add to the package. I showed you this earlier. So here's the current state of our package. That's the wrong one. Weather API 2. Here's the current state of our package. And actually, it's good I printed this out so you can see the difference. In Weather API 1, there's another directory called inst. We looked at those files. Those are just some extra R scripts. So basically, you can put anything you want in inst. What happens when you build the source package, it will copy everything from inst up one directory. So well, let me copy things over. Copy. Actually, I'll make the directory. I'm going to have 2 subdirectories. Scripts for R scripts and bash for bash scripts. And then I'm going to copy the files over from Weather API 1. So now in Weather API 2, in my inst directory, I have that bash file and that R script. Okay, so that's what's in inst right now. And what's going to happen when we build the package, it's going to take these 2 directories and move them up one directory. So in here is going to have bash and scripts. That's important to know because you don't want to create a directory inside of inst that matches any of the directories that are commonly in a package. So you should never create inst/data, for example, because that's going to conflict with this here. You should never create inst/r because that would conflict with here. And you should never put a file that's like inst/description because that will clash with this one. So you have to make sure that the files and directories inside of inst are distinct from the ones in the main package directory. Okay. And basically it's just going to copy them up one level and not really worry about them. Okay, so that's everything I want for the package. All right, so let's try to build the package. If we run clean and rebuild, that works. Run the tests. They pass, that's great. And then you can run the checks. So it's important to run the checks. This is a more thorough testing of the package. It's printing out everything it's doing here. Maybe we'll get a failure that we could try to fix. Nope, it actually worked. So this is what it should look like for a package that passes all the checks. No errors, no warnings, no notes. So you should always try to eliminate errors. You should always try to eliminate warnings. You should almost always try to eliminate notes. Sometimes there's things that come up that are not possible to eliminate, but this is the goal, that you want to get it to look like this. You can scroll through these when you run it to see all the things it's checking. When I was building the first version, Weather API 1, this failed. So there's a bunch of things I had to change to make it to work. So it's almost guaranteed that the first time you run the checks, it's not going to pass, and you have to go through and change things to make it work. But ours works for now. Okay. So this says that the package is good. And now we want to build the source package. This is going to be the thing that we can install, and then we can actually use the package. And this is something we can share with others as well. So I'm going to click Build Source Package. Okay. This looks fine. Source package written to here. So if we go up, you can see that it created a tar.gz file. So this is a sort of like a .zip file. It's a compressed file. And this contains all of the source code in here that's required to install the package. Okay, so now let's try to actually install this package. So if we go up, we can see this here. So this is a source package. It's not a package from CRAN. So when we do install.packages, we want to point to that file. So we happen to be in the directory with the package. So we can just say Weather API 2 0.1.0.tar.gz, and we want to say type equals source, and we don't want it to look in a repository. So we're going to look right here for the package, and let's try to install it. Okay, that seemed to work. And then we can do things like, oh, let's actually look. It says it installed it here. First I want to look to show you that it's actually there and see what the installed package looks like. And this is what actually gets installed. So it looks almost the same. Well, some things are quite different. The thing I want to point your attention to are one, here's our description. This is the file we created. This stays the same. And there's no inst directory, but it did, like I said, it took those subdirectories and put them in the main package directory. So now there's a subdirectory called bash, and there's a subdirectory called scripts. Now the contents of the other directories are different. For example, R is not a collection of .r files. It's a collection of objects that hold the functions in them. So a lot of this is actually quite different. Let's see, doc. Oh, this has the vignette in it. What is this? Interesting. What else? Help. This is information, I think, about the documentation for the functions. Okay, so this is quite different. Usually you don't interact with the files in the installed package. You're going to be, when you're creating a package, you're going to be interacting with the files in the source package. That's what we've been working on. But this is just to show you what the installed package looks like. All right, now we have the package installed. So I can open up R from any directory and I can type library weather API 2. So we have those functions are available to us. So I can say info equals get geo data, let's say 42 comma minus 75. And I can say get 7-day forecast of that. And this will print out the forecast. Where is this? This is Downsville, New York. It's a little bit cooler there. All right, so that's how you create a package. The main thing is you're going to be interacting with the package directory, setting up all of these files and all of these subdirectories. And as you're creating it, it's useful to have a script like this around where you can load the files as you're developing them, test them out, see that they're doing the right thing. As you're updating the documentation, you can call DevTools document. And to run your tests, you run DevTools test. What else? Now inside of build, you can clean and rebuild the package. That basically installs it locally in your session. So you can run the vignettes and things like that. There's shortcuts for running tests. This will just call DevTools test. And then you can check the package. These are these more thorough checks. And you want your package to pass all of those checks. And then to build the source, it's right here. And then to install it, you give that tar.gz file with type equals source and repos equals null. And this tar.gz file, if you want to share this with someone, you could just email them this file. They could put it on their computer and they can install it. Now, if you want to go further, you want to submit it to CRAN. That's not covered in this video, but there's some additional things you have to check and make sure are available in your package directory. But that's an issue for another day. Okay. Happy R package creating, and we'll see you next time.